Okay, so we're going to be looking at basic trig identities, and we're going to learn how to use the 9 basic trig identities. The different identities is the reciprocal identity, the quotient identity, and the Pythagorean identities. And so what's going to happen is that we use these identities to verify trig equations. Okay, so here are these trig identities here. So tangent theta is going to be sine theta over cosine theta. Another identity would be it'd be 1 over cotangent theta. So that's another, those are all the same thing. Cotangent, so you know that cotangent is the reciprocal of tangent, so you just change the reciprocal and it's cosine theta over sine theta. Or it could also be 1 over tangent theta. And then we have secant theta. That is going to be 1 over cosine theta. And it works out both ways. If we were to look at it this way, and I doubt that we would use this, but we could also say that cosine theta is going to be 1 over secant theta. And I'm not sure that we're going to be using that. And then the cosecant is 1 over sine theta, or it could be where you have sine theta would equal 1 over cosecant theta. So these are the identities that we're going to be using to verify trig equations. Here's another one, is the Pythagorean identity. And the Pythagorean identity is based off the unit circle here with a radius of 1. And so you're using the Pythagorean theorem on this. Okay, this identity really comes in handy. It's nice to know that you have cosine squared theta and sine squared theta with that, which equals 1. Okay, and you notice that how these are equivalent where the parentheses are. There's cosine squared theta, and then on right here is the cosine theta squared. That means the same thing. There's also other ways to look at the identity, is that if I was to subtract the sine squared theta on both sides, just like you would on solving equations, if you end up doing something like that, then you could also use that identity where it's going to be where cosine squared equals 1 minus sine squared theta. And then, of course, if we were to subtract the cosine squared theta on both sides, then you know that the sine squared theta is going to equal 1 minus cosine squared theta. So that is just based on this particular Pythagorean identity. All right, so let's go ahead and let's start verifying identities. So it says the other 3 are what are known as the Pythagorean identity. And so we have this 1 plus tangent squared theta equals secant squared theta. And so we're going to go ahead and use an example on this one as to how we would verify this. So we're going to get all of this in terms of sine and cosine. And so just remember, a while back is that tangent theta right here is sine theta over cosine theta. So we're going to use that identity. I can't always refer back, but I'm wanting you to be able to have your notes in front of you so that you could see this. So if I've got 1 plus tangent squared theta, I'm going to put sine squared theta over cosine squared theta equals, and then secant squared theta is 1 over cosine squared theta. Usually when you verify identities, you only verify one side at a time, okay? So on this one, you just use a little bit of your fraction tricks that you've learned in elementary school, I hope. So if I want to write this side with a single, as a single fraction. And so if I have cosine squared theta in the denominator, then what's going to happen is I'm going to be multiplying the cosine squared here and the cosine squared here. So if I was to do that, then I would end up having something along the lines of cosine squared theta plus sine squared theta all over cosine squared theta. And we're looking at verifying this, and so you will notice that cosine squared theta plus sine squared theta equals 1. So this would be 1 over cosine squared theta, which verifies it right here. So we can use this identity right here, that 1 plus tangent squared theta equals secant squared theta. All right, here's another one. Here's another Pythagorean identity. 1 plus cotangent squared theta equals 1 over cosecant squared theta. And so we're going to kind of do the same thing with this one, where we're going to use our identities here. So our cotangent is going to be cosine over sine. So it's going to be 1 plus cosine squared theta over sine squared theta equals, and then the cosecant squared is going to be the same as 1 over sine squared theta. And so we're going to verify this, that that 1 plus cotangent squared theta equals cosecant squared theta using the identities. And so same tricks here, where you've got to use your fractions here. So we have sine squared here and sine squared here. And so we would end up writing it as a single fraction. So then we would have that sine squared theta plus cosine squared theta all over sine squared theta. And in turn, sine squared theta plus cosine squared theta, that's the original identity, so it's going to be 1 over sine squared theta, which is verified right here. All right, so let's continue on. Rewrite each of the following trigonometric expressions in terms of sine and or cosine and completely simplify. So we have sine theta times the quantity of cosecant theta minus cosine theta times tangent theta. We can tackle this all kinds of different ways. We could use the distributive property first, or we can use the distributive property after using the identities, but it really doesn't matter because you're going to end up with the same answer. But I'm choosing to go ahead and distribute. So I have here so if I was to distribute here, it's going to be sine theta times cosecant theta minus sine theta times cosine theta times tangent theta. So I did the distributive property. Now the next thing I'm going to use is the identities, so that I can go ahead and get this in terms of only sine and cosine. So I have sine theta times cosecant is going to be 1 over sine theta. And then I've got sine theta. And then my tangent is going to be sine theta over cosine theta. All right, and so there's some simplifying that we could do. So we know that these cancel. We know that these cancel. And so now we have that it's 1 minus, and we have sine theta here and sine theta here. So it's 1 minus sine squared theta. Just as a reminder that sine squared theta minus or plus cosine theta squared theta equals 1. And if I was to subtract sine theta, it goes right back to this. And so we have that this equals cosine squared theta. All right, so on this next one, I'm going to go ahead and distribute right here. So now we've got cosine theta times tangent theta plus cosine theta times cotangent theta. I'm going to go ahead and get this only in terms of cosine and sine. So we have cosine theta, and then our tangent is going to be sine theta over cosine theta plus cosine theta, and then my cotangent is going to be cosine theta over sine theta. So if I were to go ahead and simplify here, these would cancel, and we have sine theta plus cosine squared theta over sine theta. And so our fraction trick, if we put this over 1, then you know we're going to be multiplying sine theta here and sine theta here to get the common denominator. And so once we get that done, then this ends up being sine squared theta plus cosine squared theta all over sine theta. And this, in turn, I just want to have fun with different colors. This would be 1 over sine theta, and you know that 1 over sine theta just equals cosecant theta. Now, originally, if you want to keep it in terms of 1 over sine theta, that's fine. I'm not going to take points off if you do that. And I'm not going to take points off if you continue on with 1 over sine theta to equal cosecant theta, because that's telling me that you're understanding this identity. So now let's go ahead and let's use simplify this trig expression. So we have secant squared theta minus tangent squared theta over cosecant theta. Just remember that secant squared theta right here, this equals 1 plus tangent squared theta. And so if I was to substitute it, I'm going to write it exactly the same way, but instead of writing secant squared theta, I'm going to write the identity of 1 plus tangent squared theta. And then keep going, minus tangent squared theta all over cosecant theta. Well, you're going to notice that we have tangent squared theta minus tangent squared theta, that equals 0. So it'll be 1 plus 0 over cosecant theta, which equals 1 over cosecant theta. And our identity tells us that 1 over cosecant equals sine theta. That was the little extra that I had talked about at the very beginning. All right, so now we have cosecant theta over 1 plus cotangent squared theta. And just remember that this is an identity, and that identity here in the denominator equals, it's one of the Pythagorean identities. And so 1 plus cotangent squared theta does equal cosecant squared theta. So if we have cosecant theta in the numerator, and I'm going to substitute 1 plus cotangent squared theta with its identity, which is cosecant squared theta. Now, one thing to remember is that whenever you see like x over x squared, and you know that if this was in the numerator to the first power, then it would just equal to the -1, but I would just cancel one of these. I think I would look at it this way. I want to explain it differently than what I had thought. So if I've got x times x, that's the same as x squared. And so in reality, if I end up canceling the x's, then I would have 1 over x, which is the same thing as what I'm doing here for the cosecant. So in the cosecant, if I've got cosecant theta over cosecant squared theta, then what's going to happen is what is in the numerator cancels, and we only take out one of them in the denominator. And so then we would end up with 1 over cosecant theta. And 1 over cosecant theta actually equals sine theta.